Hi, everyone. Welcome to another day in 90 Days of DevOps. My name is Scott Lowe, and I am going to be talking about infrastructure as code with Pulumi. I'm excited to do this session and share Pulumi with all of you. So let's jump right in. All right. So first, before we really get into the code, the core of the content, let me just a little bit about me. I have been a blogger for many years at blog.scottlowe.org. I have written some books on VMware vSphere and network automation and programmability. I used to run a podcast called the Full Stack Journey Podcast. We wrapped that up late last year. And I have worked a variety of places in my 20 plus years in the IT industry. Notably, I spent two distinct times at VMware, once coming in with Nicira, second time coming in with Heptio. I have also worked at Kong and at Pulumi. I first found Pulumi while I was working at VMware the second time, and it made a lot of sense to me for doing infrastructure as code. And so I switched from Terraform to start using Pulumi. And I hope that what I have to share with all of you will resonate as well with some of you, and that you'll find this tool to be useful. Before we really get into all about Pulumi, and I promise you I won't spend much time here. We'll spend most of it in actual live demos of the product. Why infrastructure as code? It's probably well understood now that infrastructure as code is super useful in scaling and being more efficient, enabling folks to do more with less by automating repetitive tasks, and enables you to stand up predefined configurations of cloud infrastructure across a variety of platforms repeatably, consistently. When you combine it with version control like Git, then it allows you to see what changes were made, who made those changes. It enables you to do things like GitOps-based workflows. When a commit is made to a repository that stores infrastructure as code artifacts, then they can kick off a pipeline that will automatically deploy changes to infrastructure. It is a form of documentation, but I don't recommend replacing actual good documentation with this. Even if you are being very liberal in your code comments, sometimes it's still very useful to have separate documentation that exists independent of your artifacts. And again, when using in conjunction with a version control system like Git or GitHub, it does or can simplify team configuration by enabling you to do code reviews, pull requests, shared repositories, et cetera, et cetera. So this makes it easy, for example, for me to make a change to an infrastructure as code artifact, to make that change in a pull request to a repository, request that others review that change to ensure it doesn't have any unintended or undesired effects on our infrastructure. Then they can approve that. Once that gets approved, it can kick off an automated workflow and then automatically make changes to your infrastructure, right? So that's pretty cool. There are a number of infrastructure as code products out there on the market. Probably the most well-known one is Terraform, but there are also tools like CloudFormation and others, right? Most of those use either a standard format like CloudFormation can use JSON or YAML. Some use a proprietary DSL. Terraform, for example, uses a domain-specific language or a DSL called Hash Group Configuration Language or HCL. Pulumi uses programming languages, so TypeScript, JavaScript, Golang, Python, those kinds of things. And I personally think this is beneficial as opposed to a DSL. The learning curve, just to be honest, can be a little bit steeper if you aren't already familiar with one of these programming languages. But the payoff is that you are investing in a skill that is reusable in a variety of different ways. So this isn't just for infrastructure as code. Being able to code in Python is just a useful skill. When I was writing the network programmability and automation book for O'Reilly with Jason Edelman and Christian Adele and Matt Oswald, there were whole chapters in that book about using Python and Python libraries for doing automation of physical network devices in your network. That's just one use case of being able to use skill and experience and fluency in Python for other use cases besides infrastructure as code. So investing in learning a programming language and using that programming language to define your infrastructure as code artifacts gives you a skill that can be used in a variety of other contexts and a variety of other ways to automate other things, to orchestrate other things, that sort of thing. So additionally, when you're working with programming language, there's this ecosystem of supporting tools, linters, code analysis tools, development environments, and editors that provide syntax highlighting and code completion and that sort of thing. That just make it easy or easier to write code, right? It probably goes without saying, but I think it's important to point out that using a programming language gives you this very native and intuitive support for flow control. So branching in your code or looping in your code is simple, straightforward. You're using an if statement or you're using a for loop if you need to create multiple instances of something, right? And this makes the code more readable in the long term. So when you 6 months from now comes back to code that you today wrote, it's easy to remember, oh, this if statement is right here, and I've got a code comment that talks about that, or this for statement is right here, this for loop is right here, and I can see what it does. It counts to 3, and it does this thing. Okay, cool. There are, of the plethora of infrastructure as code tools, there are others that do use programming languages. AWS CDK and CDK for Terraform are 2 examples. In both of those examples, they take the code and they compile into a different format before it actually gets applied to the cloud provider APIs. So in the CDK example, it creates CloudFormation, and then that is applied against the AWS APIs. In the Terraform or CDK for Terraform or Terraform CDK, I can't remember what the name is, sorry. It'll create HCL and then apply that and then run that through Terraform to apply against the cloud provider APIs. Pulumi is a little different in that we don't use an intermediate format. The Pulumi engine will run the code, create a graph of resources that are defined in the code and the dependencies between them, and then use that with a provider, which is a provider plugin or a resource plugin, that then goes and talks to the platforms that you've configured, whether it be AWS or Azure or Google or whatever, right? So there's no intermediate translation into another format. And if you are using another tool like Terraform, there are tools to convert and generate Pulumi code. There is also a tool called Pulumi AI that Pulumi's created. It is a large language model based, like a chatbot. It's been supplemented with Pulumi specific details, so it has access to all of the Pulumi API documentation, that kind of stuff. So, like most other large language model based tools, it's not perfect, but I have found it to be pretty useful in helping you get down the road on writing some code. So that might be some reasons why you would want to give Pulumi a try for your infrastructure as code. It does support a variety of languages. I primarily program in Golang for my infrastructure as code. In this session, I will use TypeScript because I believe TypeScript is pretty easy to pick up and the code is fairly readable. So if you aren't familiar with a programming language, TypeScript's a decent choice. A lot of you probably already have skills in Python or TypeScript, JavaScript, that kind of stuff that you can leverage. There is YAML support. It's not technically a programming language and you can't do sort of the flow control and looping, but you could write your definitions in YAML if you wanted to do that. All right, so I'm going to switch over to my terminal here in just a moment, and we're going to spend some time working with Pulumi. But before I do that, let me talk about some of the terminology I'll be using. So we use the term project to describe a set of Pulumi code and associated things. This is this strict definition is it's a directory that has a Pulumi.yaml file, a Pulumi project file. In that directory, you'll also have a program written in whatever language you're using that will have the code that uses Pulumi's software development kits or SDKs to define the infrastructure that you're wanting to create. Every project will always have at least one stack, and each stack is an independent instance with its own configuration and its own state that refers to all the infrastructure that you've defined. You can have multiple stacks, but you always have at least one stack. And if you think about it, this makes sense. There's no sense in having a project that defines infrastructure if you aren't going to have at least one instance of the infrastructure, right? Resources are the things that make up your cloud infrastructure. So we talk about defining resources in a stack. That's what we're talking about. These could be, Azure VNets or, Cloudflare zones or AWS VPCs, whatever it is you're defining in your infrastructure. And then we have the idea of inputs and outputs. Inputs are parameters that you pass to the creation of a resource. These might be, just you passing a string that says, this is the instance type I want to use. Outputs are properties of resources that are retrieved or provided by the cloud provider APIs after the resource is created. Because these operations, we make the API calls or Pulumi makes the API calls to the cloud provider to create a resource, then has to wait for that response back. So outputs are asynchronous. They're not necessarily immediately known the instant a resource is created. It might be a little bit, a few seconds or something like that. And so as you're executing your code, Pulumi builds these dependencies and knows that when you take an output of one resource and use it as the input to another resource, that creates a dependency between these two resources, right? I have to wait for the output to get resolved before I can use it as the input on the other resource. For the most part, Pulumi handles all this. There are a few use cases where you have to do something, and I'll mention a few of those, but otherwise it's pretty straightforward. So enough talk. Let's get into some actual code and looking at that. So I'm going to flip over to my terminal, and I'm in a directory in my system. I'm going to make a directory for this demo. So let's make a directory, 90 days of DevOps, and then let's change into that. And you'll see it's just a regular directory. Now I'm going to be using the Pulumi CLI here. This is the primary way that you'll interact with it. You can install the CLI on Windows, Mac, Linux. We have a Docker container that has the CLI if you want to use it inside Docker. The Docker container would be a great way to use it in a CI/CD pipeline, for example. But here I'm going to use the Pulumi new command, and the Pulumi new command just sets up a new project. Remember, a project is a directory with a project file and some code, right? So the Pulumi new command just does all the scaffolding that you need to set up a project. And if I just press enter here, it's going to give me this long list of templates, and there's like 200 and some templates. I know which template I want to use, so I'm just going to type in the name of it directly. I'm using an AWS template using the TypeScript language. Now, what this does not do is it does not install the language runtime. So you still need to have like Node.js installed if you're going to use TypeScript or JavaScript, or Python installed if you're going to use Python, or Go installed if you're going to use Go, that kind of thing. But once you do have your runtime installed, then this will automate the process of pulling down any libraries and all that kind of stuff that you need to run your program. First thing it's going to do is ask for a project name. I'll accept the default, which is the name of the directory. Then it asks for a description, I'm just going to a demo program. Obviously, you could make this more descriptive if you want. Then it creates a stack. And remember that we always have at least one stack, which is one instance of the infrastructure defined in your program. It says dev, that's fine with me, I don't care. Now, I used an AWS template here, so it's asking me which AWS region do I want to use. I'm going to deploy into US West 2. And then now it's going through and installing dependencies. Because we're using TypeScript, it's using NPM, the Node Package Manager, to install some Node dependencies for our program. Does this for you automatically. And then it will create the necessary files and all the rest of the things that have to happen for you to run Pulumi, right? And then once this is done, okay, it's done. I installed so many packages, so on and so forth. Let's look at what it created. You can see that it created some files. Most of these are associated with TypeScript. So package JSON, package lock JSON define the dependency or the dependency libraries that you're going to use. We have our Pulumi YAML file. We have our stack configuration file, which is pulumi.stackname.yaml, so Pulumi dev YAML. We have a tsconfig, which is a TypeScript specific file. Git ignore node modules, which is where all the TypeScript libraries are stored. And then the actual program in this case is index.ts. And this name will change depending on language. For TypeScript and JavaScript, it's index.ts. For Python, it's underscore, I think they call it dunder, main dunder, .py. For Golang, it's main.go, so on and so forth. Let's take a quick look at this index.ts file. This is a really straightforward file. It's what we call a starter template. It just gives you the basic scaffolding of what you need to have. Imports some libraries. These are the Pulumi software development kits or SDKs. And then it creates an S3 bucket using a resource definition or a class that is defined from the SDKs. And so I could now go and run this program. And again, flipping back over to my slides, here we go. Then we see there are some of these commands that we need to run. I'll talk about Pulumi login in a moment, but when it comes to actually performing operations on infrastructure, the ones that you're primarily going to use are preview, up, refresh, and destroy. Preview just generates a preview of the changes. Up actually runs the program and makes the changes declaratively, meaning that if no changes need to be made, then none will be made. Refresh updates the Pulumi state from the actual infrastructure state. And then destroy, well, exactly what you think it does. It destroys everything, right? So with that in mind, let's flip back over. And we're going to run a Pulumi preview. Now, before I run Pulumi preview, I just need to make it so that I can log into AWS. Okay. And so now I will run Pulumi preview. It's going to install any libraries, if plugins, if necessary. It doesn't need to in this case. It's going to run the program and then show you the output. In this case, it's going to create a bucket. Well, that's exactly what we expected it to do, right? So no problem. Now, in the classic, baking show context, I have another stack that we're going to switch to. Now that I've kind of given you some framework to understand what's going on, we're going to flip over to another stack, and we'll talk about that. I did want to talk about this Pulumi login command real quick. And to do that, I want to flip back over to my slides for just a moment and talk about backends. Now, every infrastructure as code tool that I'm aware of always has a concept of storing the state of what it's done. So Terraform has a state file. Pulumi also uses the idea of state. And that state has to be stored somewhere. And the idea behind state is if I'm going to operate declaratively, then I have to know what has happened in the past, or what I've already done, if anything, so that I can compare that to what is actually happening on the cloud providers and then reconcile those two if reconciliation is needed, right? In other words, if my state matches what's actually on the cloud provider, well, I don't need to do anything. I don't need to make any changes. But if there have been changes that have happened on the cloud provider and my state doesn't match, then I need to do something. So Pulumi supports a number of different backends. We have the Pulumi SaaS backend, which is called Pulumi Cloud. It will store states. It will store secrets for you. There is a free forever individual tier. It's what I used when I first discovered Pulumi. It's what I continue to use for my own personal projects. For companies, there are paid tiers, and then the paid tiers have all kinds of cool features. It doesn't cost you anything to sign up, and it makes it super easy to use Pulumi. So I would encourage you to go out to Pulumi Cloud at app.pulumi.com and sign up for a free forever individual tier. If you don't want to use Pulumi Cloud, and that's fine, you can also use a variety of blob storage services. So S3, Azure Blob Storage, Google Cloud Storage, whatever. And you can also store your state locally. I don't recommend this for any sort of production use, but for proof of concept, you can do that as well. Now, every time you use one of these backends, you have to log in to the backend. Now, that makes sense when you're using a SaaS service. You need to log in, authenticate to the SaaS service, get a token, that sort of thing. It kind of makes sense when using cloud object storage too. Okay, I have to make the connection to the S3 bucket, for example. Doesn't really make sense for local, but you still have to do it for workflow. And that's where that Pulumi login command comes in. Now, I have already logged in here, and you can see that my prompt shows some Pulumi information. If you're interested, by the way, this is the Starship prompt, and it shows me the current directory, the version of node that I'm using, my Pulumi identity, and the Pulumi stack name, and then I've got some AWS stuff here. And so I don't need to run Pulumi login, but if you aren't sure where you're logged in or what backend you're using or anything of that end, you can use Pulumi Whoami-V for the verbose option, and it will show you the backend that you're using. In this case, I'm logged into Pulumi Cloud using my individual tier account, right? And that's why the identity is Scott S. Lou, right? And if you were logged into an S3 bucket or something like that, you would see the backend URL reflect that accordingly, right? Okay, so we've talked about, Pulumi state has to be stored somewhere. You can store it in a blob storage. You can store it locally for POC. You can use Pulumi Cloud. You have options there, and we've seen sort of getting started with a new Pulumi project using Pulumi New that does all the scaffolding and all the installing of libraries and stuff. Let's switch over to the sort of the full-blown project that I want to show you. So we're going to switch over to this one. And all of this code is going to be available in a GitHub repository. And I'll have the URL for you in just a moment so that you can, clone it down, fork it, whatever you want to do, play with it, try it yourself, that kind of thing. So in this directory, it looks a lot like the last directory, right? This is a Pulumi project. It does have one stack. It is written using TypeScript. There are some additional files here because this is a Git repository. But otherwise, it's pretty much the same. Now let's take a look at the program itself. And I'll kind of walk through what the TypeScript in the program is doing. And then we will kick off an update, right? So first, let's just take a look at the file. I'm not going to go through this line by line. I'm just going to kind of give you a high level view of what's going on. And I encourage you, reach out to me via, GitHub with an issue, hit me up on Twitter or on the Fediverse, Mastodon, or find me in one of the Slack communities where I hang out. I'm more than happy to answer any questions. But first, we start out with importing some libraries that some SDKs, and that's these first few lines, right? Then we define some parameters that I am getting from the user. These are values I want to ask the user. This is a way to parameterize the code so that I can use it over and over again with different values, right? So you might have a set of infrastructure and you want a production version of that with, big, powerful instances and a certain, network block. And you might want a copy of that, but using smaller instances and a fewer number of them and a different network block. Well, how do you do that? The trick to doing that is to using some user-supplied parameters that then the program will use. And that's what this first few lines does, is it defines some parameters. Specifically, what is the network block that I want to use and what kind of instance do I want to use, right? Then starting in line 13, we create a VPC on AWS. Starting in line 22, we look up an AMI ID for, it says Ubuntu, but I'm actually looking up an AMI ID for a flat car container Linux. Then starting in line 32, we create a security group that allows SSH access. Going down to line 50, we create an EC2 instance and put it into a subnet. I'm going to pause here real quick to talk again about inputs and outputs. So you see that we have these properties here for defining what this instance needs to look like and how it should be configured, right? And then we have a value. In this case, we have demo AMI. Now, in scrolling back up, right, we know the demo AMI was defined up here. This is an example of using an output from one resource and using it as an input for another resource. So we took a function called getAMI, which looks up an AMI dynamically. And yes, I am firmly in the AMI has 3 syllables camp. And then we take that value, which is going to be an asynchronous value. So we have to issue the API calls and then wait for those API calls to come back. So we don't immediately know the value of what demo AMI is going to be. But Pulumi knows, okay, this is an output. So I know that I have to resolve that output, wait for that value to be available before I can use it. And that's exactly kind of what it does transparently in the background back here is it knows demo AMI, I got to wait for that function to return. Same goes for a subnet ID here on line 55. It knows it needs to create the VPC, which was defined earlier in the program, and then take the first public subnet ID. So it waits for that asynchronous output to be available. The lines in between key name and instance type, those are configuration values that we're pulling in. Same down here on line 59, where we look at the VPC security group ID. We created that security group earlier. We wait for the security group to get created and its ID to be available, and then we supply it here. And this is all part of how Pulumi creates that resource graph and understands the dependencies between the resources that are being created. Now, starting in line 62 and then continuing on is an interesting situation. There are times when things take a little bit of time to happen in the cloud, right? When I tell AWS to start an EC2 instance, it will do that, but it'll take a little bit of time for that EC2 instance to boot up, right? And so here we actually have a resource that is a boot delay. It waits 30 seconds after creating the EC2 instance, and then it proceeds, right? And to model or to create the dependency graph to know that this boot delay should wait on the instance and that the resource after the instance, which is connecting to it to do some things via Docker, to wait 30 seconds, I create dependencies using this depends on keyword. Boot delay depends on the Bastion host, right? The EC2 instance. So I create the instance, then I create the 30-second delay, and then notice farther down, I wait until after that 30-second delay before I try to create the Docker provider to connect to that instance and then launch some containers remotely. And that's what's happening down here as we're creating some containers remotely. So that's a bit of a unique instance, but it does show you how you can accomplish that here in a Pulumi program. So now that you've kind of seen what this is up, we're gonna go run this, right? We're gonna do a Pulumi up. I'm gonna do a -y here just to bypass. I'm waiting for user confirmation to approve it, but it's first gonna run a preview to show me what it's gonna do, and then it's gonna actually run the command. And the -y just says after the preview is done, just go ahead and create whatever it is you're going to create. And so we see 36 items it's going to create, and then it just immediately proceeds and starts updating. And this will take about 3 or 4 minutes. And so we will give it some time to run, and then we'll be right back. Okay, and we're back. This took just under 4 minutes to run, as you can see the duration there. And what has happened now is it has created an EC2 instance running Flatcar Container Linux. And then it created what we call an explicit provider. This is a Docker provider that connects to that instance and spins up some images. Now, I want to take a quick moment and just talk about something called outputs of a program. We talked about outputs within a program where we have a resource and it has some properties associated with that resource. But then we also have the option of exposing values that the program created or generated outside of the program. So if I run Pulumi stack output, you're going to see nothing there, right? No output values on the stack. But I'm going to fire up my editor, and we are going to add an output, and then we're going to run the program again, and you'll see it'll be far faster this time. So here is my program. And so we're just going to go down to the bottom here. And right after this, we're going to say export the instance IP address. And so we will say export const instance pub IP equals demo bastion dot public IP. Okay. And let's see. We'll save that. And let's see, we're doing some live coding here. So let's see if I got it right. Pulumi up. Now, we talked about Pulumi being declarative and knowing it doesn't need to make changes and stuff. What's going to happen is it's not going to change any of the infrastructure, right? Instead, it's just going to make a value from the infrastructure we created available outside of the program, right? So in other words, it's going to tell me what the IP address is. You could think of this as analogous to the output command in like Terraform. And so you can see it's not changing any of the resources. It's just adding an output that was in the preview. And so it's going to run through this real quick, and then it will add the output, and then I'll be able to run that Pulumi stack output command again. And you'll see I'll get the IP address of the instance, right? And so if I then say I want to SSH into that, then I'm logged in here. And if I run docker container ls, it sees here is the Docker container that I defined in my infrastructure as code program. So we see that Pulumi did exactly what we asked it to do. It created a VPC, subnets, internet gateway, NAT gateway, routes, route tables, all that jazz, launched an EC2 instance. And then after that EC2 instance was available, it used the Docker provider to connect to it and actually launch a Docker container, which I think is pretty cool. So that's what I have to show you. That's the live demo. Again, all this code is going to be available on GitHub. This is a screenshot of Pulumi Cloud. I do encourage you, if you are interested in giving Pulumi a try, sign up for one of the free forever individual tiers. Makes it really easy to use Pulumi. And then the code is available here on GitHub in the 2024-90 DoD-IAC-Pulumi repository. Feel free to file issues, submit PRs, or find me on Twitter or anywhere else online. I'd be happy to chat with you about Pulumi, infrastructure as code, whatever, right? Thanks for watching. Hope you all found this useful.